Okay, the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. All right, so first of all, well, we're going to go on to section 9.4, but do you have any questions from 9.3? Anybody?
No.
Nope. Paula, you? Any questions? 9.3?
I'm not sure. I think it was number 7.
Number 7 on 9.3?
Yeah.
Okay. Let me get that up here on the screen. Okay. Let's see here. Come on. Here we go. All right. .3, and you said number 7?
Yes.
Okay. All right. Okay. So 9.3, number 7. It says simplify the expression, and we have the fourth root of 80. Okay. Now, 80 could be broken down to 8 times 10. 8 is 2 times 2 times 2, and 10 is 2 times 5. So I have 2 to the 4th power times 5. Any question about how I got that? All right. So for the 4th root of 80 could also be written as the 4th root of 2 to the 4th power times 5. Okay. The 4th root of 2 to the 4th power is a 2 outside, and I have the 4th root of 5 inside. And there you have it.
I did have a question. So you don't put that extra 2 for the 8?
The extra 2 for the 8.
Yeah, so you know it'd be 2 times 2 times 2 times 2 is 8, and then 2 times 5 is 10.
2 times 2 times 2 is 8. 3 2s. We're multiplying, we're not adding.
Okay. Yeah, I got it. Sorry, I was confused.
Okay. All right. Any other questions you want to look at? Okay, then we'll go on to section 9.4. So close that up and move that up there. All right. So in 9.4, we're going to look at multiplying and dividing radical expressions, and also something called rationalizing the denominator, and we'll get to there eventually. So first of all, I want to look at multiplying radicals together and simplifying them. Let's say we've got the square root of 3 times the square root of 15. Okay. Now, in the previous section, we talked about how if you have the square root of a times b, you can write that as the square root of a times the square root of b. That also means that if you have the square root of a times the square root of b, you can write it as the square root of a times b. You can go either direction with it, okay? So what I could do with this is I could rewrite that like this, okay? And then, in effect, start over. And then I could say, well, that's equal to the square root of 9 times 5, choosing a perfect square factor. The square root of 9 is 3, so I get 3 square roots of 5. So that's one way of doing this problem, okay? I'm going to show you a different way in a minute, but do you have any questions about what I did there?
No.
Right? Another way you could do this is you could take the square root of 3 times the square root of 15, rewrite it as the square root of 3 times the square root of 3 times 5, 15 being 3 times 5, then rewrite it like this. But then what would this be? What's the square root of 3 times the square root of 3? That's 3. So you'd get 3 square roots of 5 either way. Okay? And it's not necessarily that one method is better than the other. I guess it's just whatever method is your preference. Here we're putting it all back together and then tearing it apart. Here we're tearing apart the little pieces so that we can combine things. But notice the square root of 3 times the square root of 3 is 3. Are you okay with that? Okay, let's take a look at another example. The square root of 5 times the square root of 15. So that would be the square root of 5 times the square root of 5 times 3, which is the square root of 5 times the square root of 5 times the square root of 3. But that would be 5, and that would be square roots of 3. Questions there? All right. I'll just keep going then. Negative 3 square roots 11 times the square root of 33. Well, that would be negative 3 times the square root of 11 times the square root of 11 times the square root of 3. Whoops, got a little extra square root there. Times 3, which would be negative 3 square roots 11 times the square root of 11 times the square root of 3. And that would be 11. So negative 3 times 11 square roots of 3. Negative 33 square roots of 3. Again, are you seeing what I'm doing? I'm taking this, peeling that off so I can put it with that to make it a whole number. Any questions? Am I going too fast? All right, I guess not. How about 2 cube roots of 16 times negative the cube root of 4? So let's see here. Here's what I'm thinking, okay? Now, at first, I looked at this and I thought, 16, I could break that down into 2 times 2 times 2 times 2. I could also break it down to 4 times 4. But what I looked at is this would be 4 times 4. That would be a 4. So now I've got 3 factors of 4 and an index of a 3. So I'm going to write this as 2 cube roots of 4 times 4 minus 3 cube roots of 4. Okay. This minus is like a negative 1 cube roots of 4. So now I've got negative 1 times 2, putting those two together. Cube root of 4 times 4 times cube root of 4, which would be negative 2 cube roots of 4 cubed, putting those together, which is negative 2 times 4, which is negative 8. Now, if I lost you there, let me know. I'll be happy to go back and go through it again or slower or whatever. The key was, since my index was a 3, I was trying to make cubes, and I thought, oh, there, that would be 3 4s under cube root symbol, or under a cube root index. Okay, we all right? I guess so. Okay. How about the cube root of 3 times the cube root of 18? 18 is 2 times 9 is 2 times 3 times 3 is 2 times 3 squared. So I've got the cube root of 3 times the cube root of 3 squared times 2, which is the cube root of 3 times the cube root of 3 squared times the cube root of 2. But what's that? That's the cube root of 3 cubed times the cube root of 2. And that would be 3 cube roots of 2. You folks following this?
Yes.
Okay. Just wanted to make sure you were still alive out there. All right. How about, let's see here. How about this one? 3 square roots of 8x times 2 square roots of 2x cubed y. So that would be 3 times 2 times the square root of 8x times 2x cubed y, which would be 6 square roots of 16x to the 4th y, which would be 6 times the square root of 16 is 4. The square root of x to the 4th is x squared. And so I end up with 24x squared square root of y. So far, so good? Okay. Now, let's do some distributing. Let's say we've got 2 square roots of 7 times 3 minus the square root of 7. So that would be 2 square roots of 7 times 3 minus 2 square roots of 7 times the square root of 7. This would be 6 square roots of 7 minus, oh, what would that be? So this would be minus 2 times the square root of 7 times the square root of 7 is 7. So I've got 6 square roots of 7 minus 14. All right, well, I'll just keep going and assume you're following. If you're not, let me know. Negative the square root of 3 times the square root of 7 minus the square root of 15. Well, that would be negative the square root of 3 times the square root of 7 minus the square root of 3 times negative the square root of 15. This would be negative the square root of 21. I can't do anything there. Negative times negative, this would be plus the square root of 3 times 15, which would be the square root of 3 times 5. This would be 3 squared. The square root of 3 squared is 3 outside. So I've got negative the square root of 21 plus 3 square roots of 5. And what I did here is that, and then that becomes 3. So I just skipped that step. Said, well, I got 2 factors of it. All right. Okay. How about this? Now we're going to FOIL 2 expressions together. I've got the square root of 2 plus 1 times the square root of 2 minus 3. So the square root of 2 times the square root of 2 minus 3 square roots of 2 plus 1 square root of 2 minus 1 times 3. Any question how I got those 4 products? Okay. The square root of 2 times the square root of 2 is 2 minus 3 square roots of 2 plus 1 square root of 2 minus 3. 2 minus 3 is negative 1, and then minus 3 of these plus 1 of these would be minus 2 square roots of 2. So negative 1 minus 2 square roots of 2. Okay. We good to go on?
Where do you get the -2? So you have -1, -2, and then square root of 2. But where do you get that -2?
So where did I get this from?
Yes.
From right here and the +1 there.
Okay, see.
All righty?
Yeah.
Let's see here. The square root of 3m plus the square root of 2n times the square root of 3m minus the square root of 2n. So the square root of 3m times the square root of 3m minus the square root of 3m times the square root of 2n plus the square root of 3m times the square root of 2n minus the square root of 2n times the square root of 2n. This would be 3m. This would be minus the square root of 6mn. This would be plus the square root of 6mn. Sorry, I didn't change colors there because it doesn't really matter. And that would be minus 2n. The middle terms cancel. After all, isn't that a conjugate pair, the difference of two squares? So the middle terms canceled out. Okay. Any questions there? All right. What's the square root of 7 squared? It's just 7, isn't it? That's like the square root of 7 times the square root of 7, which would be the square root of 7 squared, which would be 7. How about what's the cube root of 9 cubed? That would be 9, because the index and the exponent would reduce down to 1, and 9 to the 1 power is 9. What about this one? 2 square roots of 5, the quantity squared. Would that be 5? That would be 2 squared, square root of 5 squared, which is 4 times 5, which is 20, because this applies to both here and here, all right? Okay. Next idea. Okay, we talked the other day about simplifying a radical. For instance, the square root of 20 is the square root of 4 times 5 is 2 square roots of 5. So we say that simplifying the square root of 20, we get 2 square roots of 5. Simplifying a radical means kicking everything outside that we can. Another thing that we tend to do is if a radical has a fraction inside of it, we tend to try and get rid of the fraction, as in get rid of the denominator, okay? So we do something called rationalizing the denominator. Now, let's say we have this. We have the square root of 5/3, okay? So 3 is inside and is the denominator inside. If we split it up, we'd have this. So now the denominator is the square root of 3, which is not rational. We say it's irrational. If I multiply this fraction, the square root of 5 over the square root of 3, by the number 1, that's legal. But I'm going to choose my 1 as the square root of 3 over the square root of 3, because now the denominator is going to be plain old rational 3. And I have rationalized the denominator. Now in the numerator, the square root of 5 times the square root of 3 just becomes the square root of 15. Okay. So what have I done? I've rationalized the denominator. Now be careful. Right here, that 15 and that 3 cannot reduce because the 15 is inside the radical, the 3 is not. Okay, so I can't do anything there. Don't confuse, oops, this with that. Those are not the same thing. Here, we could reduce that down to the square root of 5. Here, we cannot. Okay, so be careful. All right, anyway, let's take a look at some more of these. Let's say I've got the square root of 8/7, and I want to rationalize the denominator. So that's the square root of 8 over the square root of 7. I'm going to multiply by the square root of 7 over the square root of 7 to get me 7 in the denominator. Now, in the numerator, currently I have the square root of 56. So I've rationalized the denominator. However, I can simplify the numerator. For instance, 8 can be broken down to 4 times 2. So let's take this. And let's take a look at 56, which is 8 times 7, 2 times 4 times 7, 4 times 14. That's, now why am I doing that? Because, let's see here. Trying to get some room there. That would be 2 square roots of 14 over 7. So not only did I rationalize the denominator, but I also simplified the radical in the numerator as well. So that would be the final answer there. Any questions about that problem? Okay. Here we have 8 divided by the square root of 10. We want to rationalize the denominator, so we're going to multiply by the square root of 10 over the square root of 10. That gets me 8 square roots of 10 in the numerator and 10 in the denominator, because the square root of 10 times the square root of 10 is 10. But I can reduce this down. The 8 over 10 reduces to 4 over 5. So I get 4 square roots of 10 over 5. The square root of 10 in the numerator, I could break it down to the square root of 2 times 5, but that's not going to get me anywhere. So that would be the final answer. Questions there? Okay. Let's see here. How about this one? The square root of 15b squared divided by the square root of 5b cubed. It says, rationalize each denominator. All variables represent positive real numbers, so we don't have to worry about absolute value bars. Okay. Now, there are several different ways we can approach this problem. One of them would be to go ahead and, well, let me just take you through them all, and then you can decide for yourself. One of them would be to say, well, let's just go ahead and multiply the top and the bottom by the denominator, because that'll give me a rational number in the denominator. Any questions how I got there?
No.
All right. Now, what would that give me in the numerator? That would give me, let's see, 5 times 15 is 75 b to the 5th power. Okay.
And then we can simplify the top one to 25 to the 3rd, right? Or 25
Times 3,
times
right. So then we get 5b cubed in the denominator 75 would be 25 times 3, and I'm going to write it b to the 4th times b. Since my index is a 2, I want my exponents to be 2's or multiples of 2's. And the 25, I could have written it as 5 squared, but what is the square root of 25? That's going to be a 5 outside, okay? This is stuck inside. The square root of b to the 4th would be b squared, and that's stuck inside. That's a b, so I know it's hard to tell. So I've got, what, 3b inside. Okay, so I multiply the numerator and the denominator by the denominator to rationalize the denominator. Then I simplified the numerator. Okay, but I'm not done even with this method. Now I can come back and say, well, those are going to reduce down, and that's going to reduce down, and I'm going to have the square root of 3b all over b. And my b's look too much like 6's. Let's see if I can do a better job of that. Square root of 3b all over b. Okay? So that's one way of doing this problem. Now, let's take a look at another way of doing this problem, okay? So I'm going to start with this again. Let's see here. I could put them together as a single radical. I could simplify that. Let's see, that would be a 3, and that would be, so I'd have the square root of, oh, hang on. I'd have the square root of 3 over b, because 15 over 5 is 3 over 1. B squared over b cubed is 1 over b, so I've got that, okay? Now that's that. Now we'll just multiply by the square root of b over the square root of b, and we get the square root of 3b over b. Same answer, less work. So there's another approach. Okay with that?
Yes.
All righty. I'm looking at, there's even another thing we could do. I don't know if I want to. Oh, why not? Okay, let's look at one other way we can do this. My goal here is not to confuse you. It's to show you that you have many options. Of course, I have to copy this correctly, or we'll have issues. All right. Another thing I could do is I could simplify each thing. Well, let's see. On top, I'd have b square roots of 15. On the bottom, I'd have b square roots of 5b. Okay. I could cross out the b's. So now I've got the square root of 15 over the square root of 5b. I could rewrite the top as the square root of 5 times the square root of 3. And on the bottom, the square root of 5 times the square root of b. And cross those out. And then multiply by the square root of b over the square root of b to get the square root of 3b over b. And I don't know if I like that method, but I'm just trying to show you there's a lot of different ways you can do this. Personally, I think I like this second method the best, putting these two together, simplifying it, and then going from there, rather than this where we just multiplied by that, or this. But they all work. And in a given situation, you might decide one is better than the other. Okay, having said all of that, let's look at another one. The square root of 9xy divided by the square root of 3x squared y. So I'm going to go with putting these together as a single radical. Then I'm going to simplify. So we're going to get 3 over x. Okay, the y's reduced out. The 9 over 3 became 3. So I got 3 on the top, x on the bottom. So this is the square root of 3 over the square root of x. I'm going to multiply that by the square root of x over the square root of x, and I'm going to come up with that. Just seems to me like that's the easiest way to go, at least in this case. What if nothing reduced by putting those together? Well, then I probably wouldn't put them together. But, okay. You all right with that? Questions there? Okay, how about this situation? We've got 11 divided by the square root of 75 s to the 5th power. So now the numerator and the denominator aren't both radicals. So I can't put them together in a single radical like I did in the previous problem. So now I've got a couple of options. I can multiply the top and the bottom by the bottom, immediately rationalizing the denominator and then simplify it. Or I can try and simplify the bottom first. I'm going to run both ways past you here. All right, 75 s to the 5th, square root of 75 s to the 5th. So on top, I get 11 times the square root of 75 s to the 5th. And on the bottom, I get 75 s to the 5th. Okay, so I've immediately rationalized the denominator. However, I can still do something with that. Let's see, I'm going to rewrite the numerator as 11 square roots of 5 squared times 3, that's 25 times 3, which is 75, times s to the 4th times s, all over 75 s to the 5th, okay? So I took 75 s to the 5th, broke it down into squares and 4th powers and leftovers. So now on top, I've got 11 times 5 times s squared times the square root of 3s over 75 s to the 5th. Which is 55 s squared square root of 3s over 75 s to the 5th. I know you're thinking, will this problem ever end? I can reduce 55 over 75 and make it into what? 11 over 15. S squared over s to the 5th becomes s cubed on the bottom, and I've got the square root of 3s on top. So final answer, 11 square roots of 3s over 15 s cubed. Wasn't that fun? You okay with this? Any questions there?
That was a lot to take in.
Yeah, I know. It's all recorded. You can watch it later at your own pace. But do you want me to go over any of that again?
No, it's okay.
All right. Do you want me to show you a second method of doing this problem?
Is it easier?
Well, I don't know that it's easier. It's different. Basically, what I would do is I'd go through and I'd simplify that first. I'd kick the 5 and the s to the 4th, or s squared outside. Let me just do it. You can decide for yourself. Okay. 11 over the square root of 75 s to the 5th equals 11 over the square root of 5 squared times 3 times s to the 4th times s. Now, if you'll recall, I did that, but I did it in the numerator in the previous problem. I'm just going to simplify the denominator right at the beginning. So I get 11 over 5 s to the 2nd square roots of 3s. Okay, so I took the denominator, simplified it, kicked out a 25 and an s to the fourth, got 5s squared on the outside. Now to rationalize it, I don't have to multiply it by the entire denominator, just the part that's irrational. So now I get 11 square roots of 3 over 5s squared times 3s, which is 11 square roots of 3s over what, 15s cubed. So again, it's like, do you want to simplify it first? Do you want to simplify it later? It's kind of up to you. Here, by simplifying the denominator first, I multiplied by a smaller number. Back here, I multiplied by the entire denominator to start with, and then I ended up simplifying the numerator. So I would say, you know, it's kind of your judgment call, see what you're most comfortable with. And of course, the option of just walking away and not doing it at all, that would probably be the most comfortable option, but that's not one of the options. So come on, you can do this. All right. Let's see here. I think that's it. I think I've tortured you enough for one day. I bet you'll probably agree with me there. All right. I'm going to go ahead and, if I can get the mouse in the right place here. Where are you? Ah, here we go. I'll go ahead and stop the